Lesson 1 of Unit 2, we're talking about equivalent rational expressions. So number 1, find an equivalent rational expression in lowest terms and identify the values of the variable that must be excluded to prevent division by 0. So the key thing with rational expressions is we can't be dividing by 0. So we need to figure out, when is our denominator 0? When does 4n equal 0? What happens when n equals 0? So we say that n cannot equal 0. I can't plug n equals 0 into that expression, otherwise it would be undefined. How do I simplify it? We basically factor. We factor and see if there's like terms that can divide. In the numerator, I'm going to take out a 2n, and I'm left with 1 minus 4n over 4n. Then we say, what are like terms? Well, we have n divided by n, those divide to 1. And then I have 2 divided by 4, and I'm left with a 2 in the denominator. So my final answer is 1 minus 4n over 2. That's it in simplest terms, but we have to remember that n still cannot be 0. Number 2, we want to know what values what have to be excluded from this rational expressions domain. So let's figure out, when is the denominator 0. It's always a good idea to factor. Whenever you see a rational expression and we want to simplify it or multiply, that's what we're doing in the next lesson, you always want to factor it. So in the numerator, we have x plus 6, x minus 6. That's the difference of perfect squares. In the denominator, it's a trinomial whose leading coefficient's 1. So what multiplies to negative 12? What multiplies to negative 12 that adds to negative 4? Negative 6 and positive 2. So before I start simplifying this, when is this expression undefined? It's undefined when the denominator equals 0. When does that denominator equal 0? Well, that's the zero product property, that x equals 6 or x equals negative 2. So x cannot be 6 and x cannot be negative 2. If I plug in those values, I'm going to be dividing by 0. But now that I factor this expression, I notice that there's a factor of x minus 6 in the numerator and the denominator, so those divide to 1. And we're left with x plus 6 over x plus 2. And that's our final answer in simplest form. So x cannot be 6 and x cannot be negative 2. Number 3. Well, I want to know when the denominator is 0. That's nice because that's when n equals, I'm going to add 4, when 2n equals 4, divide by 2, so n cannot equal 2. We do not want n to equal 2. I need to factor the numerator and the denominator. Whenever we want to simplify the expression, we just want to factor it and see what common factors there are in the numerator and the denominator. Well, the numerator, it's a trinomial whose leading coefficient's not 1, so on the side here I'm going to run through the AC method quickly. What multiplies to a times c? What multiplies to negative 6? That adds to negative 5. That's negative 6 and positive 1. So 3n squared minus 6n plus 1n minus 2. Group it. I can take out a 3n. I'm left with n minus 2. I want n minus 2, so I'm going to factor out a plus 1. Be careful there, because you already had... It's already, n minus 2 is already sitting there, so I can factor out a 1. And I'm left with n minus 2 times 3n plus 1. So the numerator factors into n minus 2 times 3n plus 1. The denominator factors, well, there's a GCF of 2. Notice that this expression is equivalent to this expression I just wrote because factoring is just undoing the distributive property. We're not changing the value, we're just changing the way it looks. Now that it's factored, n minus 2 is a common factor in the numerator and the denominator, so they divide to 1, and we're left with 3n plus 1 over 2. But n cannot equal 2 to prevent that division by 0. Number 4. 8y cubed minus 1 divided by 4y squared minus 1. So, let's factor this. Clearly this is not quick and easy to simplify. Just setting the denominator equal to 0 would mean I'd have to solve a quadratic, so let's get it in factored form first. The numerator, hopefully you notice that the numerator is the difference of perfect cubes. The numerator is difference of perfect cubes because that's 2y cubed minus 1 cubed. So the numerator factors into 2y minus 1, the first thing squared, so 4y squared, opposite side, multiply those two together, 2y, always positive, 1 squared is 1. Make sure you know how to factor the difference in sum of perfect cubes. It's just a factoring strategy. It's a pattern that you need to be able to apply. The denominator, what is the denominator? The denominator is 4y squared minus 1. That's the difference of perfect squares. That's 2y minus 1, 2y plus 1. Before I start dividing things out here, what values are undefined in the denominator when 2y minus 1 equals 0 and when 2y plus 1 equals 0? So 2y equals 1. Y cannot equal 1/2. I cannot plug a 1/2 into that original expression. Subtract 1, 2y equals -1, and I cannot plug in y equals -1/2. So the values that we exclude are y equals plus or minus 1/2. Now we can actually simplify this because both of these have a common factor of 2y minus 1, so they divide to 1, and I'm left with 4y squared plus 2y plus 1 over 2y plus 1. Now we know whenever we factor the difference of perfect cubes, 99% of the time, this quadratic will not be factorable, so we don't need to worry about that. So that's our final answer there. Notice that we still include y cannot be 1/2, even though that's not an exclusion for this expression, it's still excluded from the original expression. Number 5, determine whether or not the rational expressions given are equivalent when x is not -1, not -2, and 3. Well, clearly those values were excluded because that's when the denominators would be 0. So, they're equivalent if they can simplify down to the same value. So x plus 4 divided by x plus 2 times x minus 3. There's nothing I can really do to that rational expression. I could multiply the denominator out, but that wouldn't get me anywhere. Because I like it when it's in, we like rational expressions when they're in factored form. So there's nothing to simplify there, so we're going to leave that. This next rational expression, though, if we look at the numerator up there, that's a trinomial that we can factor. That's a trinomial that factors into, well, it's a leading coefficient of 1, which is good. What multiplies to 4 that adds to 5? Well, that's 4 and 1. Over x plus 1 times x plus 2 times x minus 3. So all we did there was we factored the numerator. Now that it's in factored form, I notice that there's a common factor of x plus 1 in both the numerator and the denominator, so that doesn't cancel out, it does, it divides to 1. And we're left with that expression is actually equivalent to x plus 4 over x plus 2 times x minus 3, which is exactly what we wanted it to be equivalent to. So yes, they are equivalent is because I can manipulate this second expression to make it look like the first one. They look different, those two expressions, but they always have the same value. They always have the same value when x is not -1, -2, or +3. Number 6, Jen expressed that expression in lowest terms. And clearly she excluded x equals 3 because that's when the denominator would be 0. Explain what Jen did incorrectly and fix her mistake. So let's deal with the expression that Jen started with. Jen had 9 minus x squared over x minus 3 cubed. Well, the numerator, that's the difference of perfect squares. That's 3 minus x times x plus 3. Sorry, not x plus 3. 3 plus x. Notice how the 9 is in the front seat. So when I factor it, 3 is going to be in the front seat. Don't panic because x is not in the front. 9 is the first term, so it goes in the front. What does it mean to cube something? What does x minus 3 cubed actually mean? That means I have 3x minus 3 being multiplied together. So somehow Jen ended up with 3 plus x over x minus 3 squared. So there is something that can be simplified here. And this is a big idea that we always need to look out for. 3 minus x We wish that would divide out an x minus 1, x minus 3, but what happens is they do divide out, but they don't divide to 1, they leave behind a negative 1. Why does that happen? 3 minus x is actually negative 1 times x minus 3. We could redistribute that in, negative x plus 3, and then use the commutative property. So 3 minus x is negative 1 times x minus 3. So 3 minus x and x minus 3 do divide out, but they leave behind that negative 1. So what Jen should have had as her final answer was negative 1 times 3 plus x over x minus 3 squared, because I only have 2 factors of those left now. So we always, always, always need to look out for this 3 minus x and x minus 3 relationship, that a minus b divided by b minus a. They do simplify. They just don't cancel out. That's why I don't like using the word cancel out, is because they do simplify, they just simplify to negative 1. That's all for lesson 1 here, is because those 4 review questions that used to be there from Unit 1 are now on our weekly assignment that is going to be due on Friday. So make sure that you are not saving that weekly assignment until Thursday night. Make sure you're starting that weekly now, getting through, maybe even do 1 or 2 questions every night, so that you're not leaving that weekly for the last minute.